So in Chapter 2, we're going to start solving equations. So the first question we have to ask ourselves is, what is the goal when we solve an equation? And the simple answer to that is that you want to isolate your variable. Now your variable might be x, it might be y, it might be a. It's the letter that represents one of the numbers that's there. Typically you'll see x, y, and z. They're the three most popular. But the fact is you want to isolate the variable. So what does isolate the variable mean? It means you want the variable, whatever that happens to be, on one side, and you want some number over here. You want the x all by itself, the word isolate. So the next question we ask ourselves is, what is an inverse operation? And the reason we ask ourselves what an inverse operation is, that's how we're going to isolate the variable. So for example, an inverse operation, if we're talking about addition, what's the inverse operation? Well, subtraction. And vice versa. If I have multiplication, well, now we're talking about division. And remember, division can be written like this. It can be written with a slash, or it could simply just be some kind of a fraction. We're going to do other inverse operations throughout the year, for example, squares and square roots. But we're going to focus on these right now. And we're only going to look at 1 and 2-step equations in this video. So let's go onto your packet and pull the questions that are there. Let's look at question number 1. X minus 5 equals negative 13. Now remember, we want to isolate the variable. So we want x to be by itself. Which means we want this term, and remember in class I said, put boxes around things and include the sign. We want this to disappear. Well, what's the inverse? What's the opposite of negative 5? Well, the answer is positive 5. If it helps you to draw a line down the page, you need to remember that you need to do the 5 to one side and you need to do it to the other, because an equation is nothing more than a scale. It's a balance. Well, then if I take negative 5 and positive 5, they're going to cancel each other out because they're inverse operations. They're going to give me 0 essentially, which means I've now got the x by itself. Negative 13 plus 5, opposite signs, which keep in mind means I'm just doing 13 minus 5, which gives me 8. I'm taking the sign of the larger of the two, so my answer ends up being x equals negative 8. And we'll talk in class how to check that. Let's move to another example here, and let's go down the page to number 3. Well, the first thing I'm going to do here is I want to clean this up. We do not like having two signs next to each other. Okay, that's going to cause confusion. Do not try and handle an equation with two signs next to each other. First thing you want to do is ask yourself, well, if I'm subtracting a negative, so we have two signs next to each other that are the same. Remember, if you have two signs next to each other and they're the same, it's nothing more than addition. And now we're going to handle this the same way. Inverse operation. Again, if it helps draw that line down the page, go ahead and do it. Negative 8 and negative 4, they're the same sign, so 8 plus 4 is 12. And it's got to be negative. So my answer ends up being x equals negative 12. What if we have a multiplication question here? I'm moving down to number 6. Well, in this particular case, this is saying to me negative 4 times x equals 1. Well, the inverse of multiplication of negative 4 would be divide by negative 4. And again, I have to do it to both sides. Well, if I take a number and I multiply by negative 4, and then I divide by negative 4, these are essentially going to cancel each other out because they're inverse operations. It's going to allow the x to come along, and just the x. Now, a lot of people say, well, what do I do over here? 4 doesn't go into 1. Well, if you really want to turn it into a decimal, feel free. But just leave it as 1/4. One of the terms is negative, So the whole answer is negative. If they were both negative, it would have been positive. But in this case, just because the 4 is negative, the answer ends up being x equals negative 1/4. Now over here, I have x divided by negative 5. And this is number 7 in your packet. Well, if I'm taking a number and I'm dividing by something, the inverse of that would be multiplication. So I'm going to multiply this entire side by negative 5. Which means I'm going to multiply this entire side by negative 5. Because you have to do what you do one side, you have to do to the other. Now, I'm taking this x, I'm dividing, and I'm multiplying. Please don't try and do this and tell me this is negative 5x. These cancel each other out because you're dividing and you're multiplying. Since you're doing that, you're doing the inverse operation, you end up back where you started, which in this case is x. Now I have 30 times 5, which is 150. A negative times a negative is a positive. So my answer in this case ends up being positive 150. Let's turn the page and go to number 11. We'll just look at one two-step equation. These I strongly suggest drawing the line down the middle of the page. Now what you want to do here is you want to you're undoing something. So we're almost thinking about working the order of operations backwards. The first thing I want to do is take care of this. Don't do the division and multiplication first. Do the addition and subtraction first, because we're undoing something here. I'm going to subtract 3 from both sides, because it's the inverse operation. My signs don't match. They're opposites. That means the 3x comes along because the 3 and the 3 cancel. 48 minus 3 is 45. Now it's just a one-step equation in which I do a little bit of division. The 3's cancel, which just gives me x, and I end up with 15. And that's a two-step equation because we had to do one step here and one step here. In the next lesson, we'll look at what if there's more than two steps. What if we talk about multi-step equations?